F vertical, I call this FA, and I call this here horizontal A. And I call this here FB, because this point is point A and this is point B, all right? And I call this here horizontal B, all right? So now I have 4 unknowns, right? So my number of unknowns is really FA, HA, FB, and HB, all right? So now I have to come up with equations in order to solve these 4 unknowns. How many equations do I need for 4 unknowns? I need 4 equations, all right? So what the most important rule in any area of engineering is the equilibriums. So what are the equilibriums? Can you tell me? The sum of forces in horizontal direction is 0. Because if it is not 0, we will have failure, right? Everything needs to be in equilibrium, right? So which means if you stand on this ground, your dead weight, there is a counter force acting in the ground in order to keep you standing. Otherwise, if the soil would fail under this load, it will fall down. So now what we can do is we can make that the sum of vertical forces is 0. It has to be 0, right? This is one rule. The other equilibrium is the sum of horizontal forces needs to be 0. We can say that the sum of moments about one point, for example, I can say here the sum about this point C, all these forces I collect, they need to be 0. And then what I could also do, these are only 3 equations, I need one more. I can actually cut this one piece out and just look at this system here. Half the, as a quarter of a circle. Here I have my force, here I would have vertical and horizontal, and since this is a hinge, no moment, and here I would have my FA and my HA, and I can make here also another equilibrium, let's say the sum of moments about C, if that is called C, right, needs to be 0. And then I have 4 equations. And I did this for you, and I will send you, if you could, I will get all your email addresses. I would say this is a great construction. I mean, you know, this is, let's continue doing this. So what happened? What happened? Did you see it? It was kind of pretty much following the ideal curve. That we figured this out visually already, right? So when we did this cosmetics here, Angela already said, okay, here is kind of a kick. So what happened is this force distributed the loadings, but at that point we got a huge horizontal component. Now look at this. If I have a resultant here, like this, and I can always bring the vertical in and my horizontal. This huge horizontal load was at a certain point not anymore possible to transfer into the other bricks without failing. So there was sudden displacement, it failed. But we were close to the limit anyway, so I think we did these tests before. How many bricks did we have? 6 or something like this, right? We stuck on top of each other.
We built it with 17, right? Or 19?
19.
Can you count them? Or is that before that?
All right, so now we need to start building. It's 11:30. So we need. So now let's do the following thing. What would happen now if we?
So we got 6 on
What would happen now if we decide to go towards Calatrava's design and make it actually?
I think it's going to be one and done.
Wow.
Whoa! No more.
Just like this.
Yeah.
Stepwise actually. So now we can really get the force.
Now we can load it.
Right.
What?
We're so good.
The fourth brick.
It's okay.
That's because it's loaded not.
It's
It's not loaded on the horizontal, vertically, right?
yeah. So I mean, there's a huge force building up in arch direction, which helps these bricks.
Oh my God, we're on the
to,
fifth brick.
to develop the
I feel like this
friction,
helped more
you
than
know?
the
That
other
last one was 6, right? 6 bricks.
Wait, and we're
The other one was 6 bricks. If this holds 6 bricks. Come on, Jane.
one. Oh, we're switching it up.